forget to write.
Yes, yeah, maybe, yeah.
Intento inglés. Hello? Okay, so thank you very much. My name is Fernando Alonso-Marroquin. The second name there, Ghulam. Appears is couldn't come. We got a job in Greenland. I am the supervisor, so I'm going to speak on his behalf. So we have a quite multidisciplinary group. Ghulam is engineering. I am physicist. Arianna is architect, and Vanessa is a soil scientist. So in physics, we talk about four forces in the universe: electrical force, electromagnetic force, nuclear force, and heavy force. So I'm quite a renegade physics. I don't think there are four forces in the universe. I think there is only two forces in the universe. That is entropy, that is the tendency of all the systems to disorganize and become homogeneous, 1.5 Boltzmanns. And the other force that has been not included in physics is the synergy, that is the tendency of the systems to interact and self-organize in a way that they perform much better than when they act individually. So synergy is an important force in the universe. Synergy is the force that produces life. Entropy takes away life. And I think we can use this force, the synergy, to achieve some goals. For example, in this case, is to reduce carbon footprint, mitigate the effects of global warming by creating synergy between the humans, the soil, and the environment. So we talk about off-grid technology, and it's not because we wanted everybody to go off-grid. So we still need a network, but we believe that the houses need to have off-grid components to reduce the dependence of the grid and to have a backup plan in case of emergency when the networks cannot work. So, where is the... Okay, so our plan is to develop an off-grid house, and we started doing the component of the off-grid house. So this off-grid house have an off-grid systems to treat water, gray water, that is made with staircase systems, and off-grid toilet, double roof have a solar panels and a green roof that have a synergy between these both systems. And we have also a green curtain that reduces the indoor temperature without using too much power. So I'm going to talk about gray water system. Our work was to find a way to treat in a natural way the gray water. So the gray water, so water has been classified by us by A, B, C, D, E, F. So the worst gray water is the gray water from the laundry because it has microplastics. And the most benign gray water is the water from the vanity. It has just soap, it's a little bit alkaline. Yes, it has some pathogens, a minor quantity of pathogens, and we use these stair-like systems to treat this water using the only force, the gravitational force only. And this water is not a potable water, you cannot drink that way, but you can use for toilet flushing or for irrigations. So we do a certain case of test in this gray water. It's a DNS test. So we want to test how the microbials respond to this gray water. So this DNS test is quite expensive. We also have a T-bag test that is much cheaper. So we use T-bags. We grow the T-bags in the ground. And we we check how the debug decompose, and according to the composition rate, we can estimate how active are the microorganisms in the soil, and how much material, organic material, is fixed into the soil. Okay, so these are some of the results. So we found out that the soil itself reduced the pathogens very efficiently. And this is the result of the debug test. So you can see the debug decomposed almost exponentially, but it's not decomposed completely. So the remnant material is called stabilizations, that is the organic material that is fixed into the soil. And the slope of the exponential, the formula, the exponential slope, give us an idea of the decomposition that is directly proportional to the microbial activity. So, the DNS test provides more information because we can go take the sample into the lab and we can have taxonomical classifications and we can see what is the biodiversity, how the biodiversity change with the with the action of putting rainwater and how the population change. Yes, so the green curtain, so I just need to talk because the time is very limited. The green curtain is a system to air conditioner system. So we put a living system between the window and the indoor environment. And this curtain is going to suck energy by evapotranspirations. So we reduce the necessity of air conditioner heating, and we have found that this system regulates itself. It means that it starts to act when it is very hot. So I don't have time to talk about this, but this system reduces significantly the temperature in hot days, in heat waves. And this another system is a double roof, where we achieve synergy between the solar panels and the green roof. Just putting the plants, the green roof behind the solar panels. So the solar panels produce 80% of the solar radiation converted into heat. How can we handle this heat? We can allow the plants to evapotranspirate, and this evapotranspiration is going to cool down the solar panels, and the solar panels will have more efficiency. It's going to increase the lifetime of the solar panels, so we can have an increase of the electricity yield of 18%. The number is somewhere here. The yield will increase 18%. And this plan is we are going to benefit because there are many plants that they don't like the direct solar sun. They wanted to have diffused solar sun. So this is a perfect synergy between the solar panels and the green roof. So we have not many improvement in the air comfort because the green roof produces humidity. So there are reduction of the temperature, but increase of the humidity, but the air comfort is the same. The main benefit is in the solar panels. So they benefit because they will cool down because of the evapotranspiration of the plants. Okay, so the off-grid toilet is another system. How many minutes do we have? One. Yes. This system, so we have proposed a system when we put earthworms as an integral part of the system. So the earthworms will capture the nutrients in the human manure and put back into environment. So we have proposed two different toilet systems here just to recirculate. So close the loop in between the humans and natural interactions. So human manure has carbon, nitrogen, phosphorus, potassium, and instead of converting this into waste, we produce this into fertilizer. Based on these two designs, that is based on the Swedish toilet design or the Japanese toilet design. So we have working in the components, and we wanted to integrate these other components, and we want to build this house in the Middle East in a very hot environment. Will be tested in the future. Sorry for the delay. Thank you very much.
So any question from the audience?